Okay, let me go over, think about not having this on. What I'm doing first is returning all papers to you. So any labs or tests that you haven't turned in yet, this is when, once I return them to you, I can't take any more. Yeah, I'll take them now, yeah. Good deal, thank you. It is the final. I think I don't keep up with the numbers that much, but the last test is the one on first thing in thermal physics that we did. That's the last test. Okay, so I'm returning the papers first, and then this is Monique, right? Okay. Returning the papers first, and then we'll proceed to do the lab. And once we've done the lab, I'll give you the test, and that'll be a take-home. Now, let's talk about how to and what to do from that point on. If you want to stay and finish the test today, you're perfectly fine to do so. Okay, I'll be here till 9:15 tonight. So if you want to get it done today, I'll be here till 9:15. Now, if you want to turn it in tomorrow, that would be fine too. I'm here from 7:45 in the morning until 12 noon, or a little before 12 noon. I'll be in my office. Does everybody know where my office is? Okay? If not, I'll show you on the map there, pointed out to you. Okay, from 12 to 2 approximately tomorrow, a little before 12, it may go a little after 2, I've got a final exam, so I'll be up here in the classroom then, most of that time. Okay, then from 2 to 5:40, I'll be back in my office. So if you want to turn it in tomorrow, in person, 7:45 till close to 12, or 2 to, or somewhere around 2 until 5:15, I'll be in the office. If you want to turn it into me in the classroom around 12-ish to 2-ish, I'll be up here in the classroom. Okay, Wednesday is technically when it's due, but anytime between 7:45 in the morning and 9:15 at night. 13 and a half hours to pick from. Bring it in anytime Wednesday. Thursday, the very latest, I'll be here from 7:45 in the morning. Please, if you have anything else to turn in, get it to me before noon on Thursday, because technically I think grades are due in by noon on Friday, but I've got an infusion on Friday, so I will not be on campus at all, either campus. I will be at the Kirkland Clinic, and I will be there all day long. It usually takes just about all day. I'll be there probably from 7 in the morning until 3:30, 4:30 in the afternoon. I've been there later, but hopefully it won't take later. So I need everything by noon on Thursday so I can get everything graded and the grades in Blackboard and put on the system and done. Now, some of you are transient students, right? Yep. Okay, I had this question asked in the last class. I don't know the full answer to it. Is this the only class you're taking, or some of you taking another one as well? Only one. You're taking two. You're
I take an online class.
And online, are you already finished with that?
Yeah, I'll finish June.
Oh, okay, yeah, so you finished that time at midterm. This is Brianna, right? Okay. Yeah, thank you. I'm sorry? No, I haven't. Okay. Now, I'm going to get these screwed up if I don't watch it. Okay. For those who need your grades sent to your home school, what you need to watch for, and this is a little crazy the way we do things here, I whittled down the grading by more than 3/4 over the weekend. Didn't quite get all of it done, but did. I got all your class, this class done. All the first 2 classes done. I just didn't get all the 4th class today done, nor the 2 classes tomorrow, but they're smaller. So now I've gotten almost as many turned in today as I had done over the weekend, so I've still got the pile to do. But when I get all the grading done, then I'll get it on Blackboard. So what you should watch for is watch on Blackboard, and when you see your grade entered there, now I don't just mean labs and tests, your final grade. There will be all your labs will be in, all your tests will be in, your paper will be in, and then you'll have the last test will be called the final exam, and then you'll have a final average, and then you'll have a final grade. All the rest will be numbers. The final grade's a letter grade, A through F, right? So, hopefully no else, okay. So when you see that on Blackboard, then that means I've probably already put it on the system, okay? Now, once it's on the system, you won't be able to see that, and here's why. We have such an archaic system here. They only have like 16 ports or something like that, maybe more than that, but that's the last I heard. And that means not more than 16 people can be on at any one time doing the same thing. So that means if we got 16 people looking for the grades on Student Suite, no faculty member can put grades in on Faculty Suite. So what they do is they block students during final exam week so we can get the grades in, and then once the grades are in, they open it back up for students, okay? So you will not be able to see that final grade on the Student Suite until they open it back up after finals are over with. But you can see that final grade on Blackboard. And once you see it there, that means I'm within a very short time of having turned it in to the registrar's office. So then you can contact the registrar's office and see about getting your transfer done. Now, what I would recommend is when you leave class today, go by the records office and find out the process of getting your grade thing. I think it's all done online, but they've got a computer there and they'll walk you through it right there in the records office. Does everyone know where the records office is? Anyone who does not? It's not really hard to get to. If at the end of class I'm free, I'll walk you down there, okay? So go on and check with them, let them know that you need your thing transferred as soon as I get the grades in, and they will tell you what you need to do to make sure that's done. Does that make sense? Okay. So I'm hoping to have lots of grading time tomorrow, Wednesday, and Thursday. And I don't have too many things coming in so late, but we'll see. So once you find out from them, then follow that up with, your but they'll tell you what you need to do, and then you do it. Okay. All right. Any questions? Okay. What I'm going to do then is pause Screencast-O-Matic. Okay. I'm going to pass out to you the lab, and you can be reading the lab. I'm going to take it to the guys next door too, and it's going to take me just a little while to set it up. I'd rather get this set up now because otherwise it's going to make everybody later doing it if I don't set it up now. And I've got a little bit of running around to do so. So let me I'll turn this off and turn this off, or pause this. Hold on. Each team has 2 thermometers, and you identify which one's thermometer 1 and which one's thermometer 2. Somehow you figure it out. The color of the, red and silver, black, yellow background, white background. Figure out some way that you can tell the difference. The scale, whatever. And if you need to, make a mark on one. That one's 1 and the other's 2. Does everybody know which is your team 1, which is thermometer 1 and what thermometer 2? And you've got to be able to recognize your thermometer amidst all the other thermometers. Okay? So if you will, like some of them have, most of them have numbers on them, but one I think doesn't. And a couple of them are really hard to read. Okay? So you got your thermometer, you can recognize yours, you know which one's 1 and 2. So what we're going to do is verify the lower fixed point of the temperature. Now we have back here a thing of ice, and this one's really cold ice. Here you go. Okay, join one of the teams of 2, which is one of those back there. So those are 2 teams of 2, join any one of them. What's that? Sure. That stuff you're turning in?
Yeah, it's my paper on my lab.
Okay. Put it right there. Mark you here. And we'll find. That's it. I don't recall. Have you done test 7? Well, then you can test 7. And we'll have test 7 in the other room. Okay, sorry about that. Okay. Have you all gotten to know your thermometers well? Okay, good. What we have in the back here, what I was starting to say before he came in, is I've had this ice sitting here. Very little of it is melted, so I'm going to help it along a little bit. Okay. I think all of you can get your thermometers in there and get the bulb down into the water. Okay? So if you want to do that, do so. Get your thermometers in the water, know where they are, recognize yours, which one's 1 and which one's 2. What's that? No. That's only 1. Huh? No. We put both Both of them C. Okay. But you need to know which one's 1 and which one's 2. Okay. Stay away from this. This is very hot. I don't want anyone getting burned. Okay, the teams are putting their thermometers into the water. And while we're doing that, let's continue on. Well, okay. Sorry, I should have had you do this when you were back there. Take a look at your thermometers now and see what they're reading. They may still be dropping, coming down to that, but see what they're reading. You can do just one of them if you want to, but just call out some numbers of what they're reading. Okay, now if you pull them out of the water, you probably are going to get a bad reading. Can you tell without pulling them out of the water? Just call out some of the readings you hear. 5 degrees. Is it still dropping or does it look fairly steady? Steady. Okay. All right. We'll wait a few minutes and go back and check again. Okay. Does someone have a phone or other device that you could get the barometric pressure of Bessemer right now? Or as close to now as you can get it. Barometric pressure here in Bessemer. That's where we are.
It's 30, was it, HG?
Okay, 30. Does it have a decimal with it?
That's pressure, yeah.
Second?
That's the pressure, yeah.
Okay.
That's the pressure, yeah.
30, just 30 with no decimal.
30.
Okay, 30. Okay. And I understood you say inches of HG, right? Okay. Anyone know what that means? 30 inches of mercury. Hg is the symbol for mercury, the chemical symbol for mercury. Now your lab, if you've read that, you'll notice they talk about standard barometric pressure in what? As being what? Front page, middle paragraph. Bold face. Standard barometric pressure. Okay, 760 millimeter of mercury. So we need to convert our 30 inches to millimeters. Now we might need to go through 2 conversions there. So blank blank, possibly another blank blank, equal blank millimeters mercury. Okay? Now, when you make these conversions, always put the units in their place. What conversion do you think we need to make first? You go from inches to millimeters. To centimeters. So what unit will go where? These are numbers, these are units. Always put the units in the place. Which one goes where? Inches on the bottom. Very good. That puts centimeters on top. Does anyone recall what the conversion is from inches to centimeters or centimeters to inches? It's an exact conversion. If any of you have your book, it's probably in the front or back inside cover of your book. Or you can look it up.
1 inch is 25 millimeters.
Say again?
1 inch is 25 millimeters, so 1 inch is 2.5.
Okay, not quite, but close. So it's 2.54 centimeters is 1 inch. That is exact. That's why I didn't want you even to round it to 2.5. 2.54 centimeters is 1 inch. 2.54 of your little fingernails to make 1 thumb joint. That looks about right. Okay? They don't exact. Okay, so that gets rid of the inches of mercury. Now you've got centimeters of mercury. Now you got to get from centimeters to millimeters. So what unit do you put where?
There's
Say again?
10 millimeters.
Which one is what? Centimeters on the bottom and millimeters on top. And what's the conversion millimeters to centimeters, or vice versa? How many of one makes the other?
10 millimeters every centimeter.
10 millimeters makes exactly 1 centimeter. Okay? So now we can multiply across, and this will be 300 times 2.54. Someone got a calculator and can do that.
672.
Say again?
762. I think it's 762.
762? Is that what you said? That sounds reasonable. Everybody else get it? So that means right now in Bessemer, Alabama, join one of those two teams at the back. There's two teams at that table. Both of them have 2 people each. Join one of those to make it 3. Okay. Mark. Raven here. Okay. Now, what does that mean? What did it say standard barometric pressure was? 760. We're at 762. Did someone check his math? That sounds right. It is. Okay, 762. So we're actually 2 millimeters above normal. Okay? Now if you read down just a couple more lines in there, you see an atmospheric pressure change that increases the height of mercury will increase the boiling point by 0.37 degrees Celsius. So how much of an increase of pressure do we have? 2 millimeters of mercury. That's how much we are above normal. Now on your back page, not really the back page, next to the back page, where you have your trials, you can change those trials to be thermometer 1 and thermometer 2. On page 152, trial 1 will be thermometer 1 and trial 2 will be thermometer 2. We're not going to do 2 trials, we're going to do 2 thermometers. Okay? Now, if you go down to your, on page 162, that near the middle of that table, it says barometric pressure. That's where you put 30 inches of mercury, as read off of Nick's phone, right? Or whoever had it. Okay? Also put in there, if you want to put the calculation you made, that's fine, but also put in 760 millimeters of mercury. 762 millimeters of mercury. Okay? You see that? It says barometric pressure? Near the middle of the page. Page 152. Deviation from normal, plus or minus. What are we? Plus 2 millimeters of mercury. Okay? Now, what's that? Okay. Now, if you notice back on the front page, 147, it says that an increase in increase in the height of column mercury will change the boiling point, increase the boiling point by 0.037 degrees Celsius for each 1.0 millimeters of mercury. How many millimeters of mercury do we have? 2. So multiply that by 2, and that gives you 0.074 degrees Celsius. Can any of you read 0.074 on your thermometers? I can't. I'm not even sure I can read 0.1. So this is negligible. I am just absolutely amazed. Just about every time we do this lab, we're either right at normal atmospheric pressure or a little above it. And I thought this far above sea level, we'd bound to be a little bit below. But in the physical science class, we learned that the equator is always at low temperature, low pressure, because the air heats and here's your lab. Join any team that has 3 people in it. This team has 4, this one has 3, this one will be fine. One of those has 3. So either one of those 2 teams. And Darius is here. Okay. Recorder is recording. Okay, that's good to know. All right, I don't know how much of that was missed, but I'm going to put it on pause now. I have no way of knowing. Okay, yeah. All right, okay. I was wondering if anyone was that far along. Okay. Now, everybody's drawn your graph, right? Everybody got drawn your graph? Okay. Now, depends on where you put the y-axis. If you did minus 20, 0, 20, 40, 60, 80, 100, 120, then wherever your y-axis is, that's going to be your y-intercept, where that line that you had crosses that y-axis. Okay? So, I take it from what your question is that everybody's already done number 1 on page 151. Is that right? What is the value of the slope? You've all calculated the slope? Okay, everybody got it? Let me hear some representative values.
1.8.
1.8? Is that about what you're getting? Okay. What is the meaning of that slope?
It's the change in Celsius to degrees.
Okay.
The multiplier between Celsius and degrees.
Okay. It's, think of it, rise over run. What was your rise here?
The rise is Fahrenheit.
Fahrenheit. So it's change of Fahrenheit per change of degree Celsius. Okay? So that is the meaning. So there's 2 questions for that. Be sure you answer them both. Number 1 was, what is the value of the slope? And what's the meaning of the slope? Then the second question says, what is the value of the y-intercept? You read that off the graph, wherever you put that y-axis to be, the 0, then what is that? What is the value on this? Yeah. Okay. Well, where was your y-axis? You did start. No, did you start down here at 0?
Yes.
Okay. Good. Okay. Yeah. So wherever your 0 was on Celsius, that y-axis above that, that's going to be your. So what values did you get? Give me some representative values.
Which one?
For the y-intercept.
0 and 32.
Say again?
0 and 30 Celsius is about 32.
Okay, the y-intercept would be 32 then. Is that what you got? Okay? That sounds about right. Okay, now, the slope-intercept form for the equation y is equal to mx plus b. Now, does everybody have what you need off the board here of converting our pressure in inches of mercury to millimeters of mercury? Does everybody have this? Those who came in late. Everybody got this?
Yes.
Okay, you were here. All right, you just took your picture. Okay. All right. Okay. Now, remember the good old algebra. Y is equal to mx plus b. What's your y in this problem? What's on your vertical scale? degrees Fahrenheit. What is your M? Didn't you just calculate that? That's the slope. First part of answer 1. What is your X? What's on your horizontal axis? Degrees Celsius. And what was your B? That's your y-intercept. That was your answer to number 2. So, if you fill in what you gathered, this is degrees Fahrenheit is equal to whatever you calculated your slope to be times degrees Celsius plus whatever you found the y-intercept to be. That is your that is the equation. It says use this information to write the equation of the Celsius Fahrenheit temperature graph. What's the meaning of that equation? Have you seen it before? What's that? I'm sorry. Yeah, no, but when you put in what values those are, degrees Fahrenheit, the slope that you got, degrees Celsius, and whatever y-intercept you got. That equation right there, write it in with those things. Instead of y, put degrees Fahrenheit. Instead of slope, M, put whatever slope you found. X is degrees Celsius. Plus B, whatever your y-intercept was. Okay? What equation do you have? Does anyone want to come right there's on the board? Okay, come do it.
So we want like that, right?
Yeah, that's fine. What's that awfully close to? Have you seen anything like that before today? That is your conversion factor. That is the same one you used when you were making your conversion earlier, wasn't it? Now, you may have a different number here, but it'll be close to that. You may have a different number there, but it'll be close to it. But that's exactly what you used. You used 9 over 5. Anyone poke that in your calculator and see what 9 divided by 5 is? 1.8. So that's exactly what you did. You have just, so what is the meaning of that equation? That's your Celsius to Fahrenheit conversion formula. Right? Everybody got it? Everybody finished? Anyone still working? If you and your team are finished, come gather around this area back here. Any teams are still working, we'll let them finish. I don't know if y'all can see it. Can you see a little steam coming out of that? Okay. I've got a little bit of water in that can, and it's pretty close to boiling, I'm sure. Okay, this is the bottom. This is the very bottom. Invitation to inquiry. I'm doing mostly number 1. Okay? That's all we're doing, number 1. I guess some people are working on the questions. You do have those questions. What is it, 5 questions? Okay. Okay. 5 questions. You can do those later if you want to, but please don't forget to do those 5 questions. That's part of your lab too. Okay. Let's do a cup of water in there and boiling water. We didn't talk about Boyle's Law and Charles's Law. Does anyone know what they, especially Boyle's Law, is? It's basically the pressure times the volume. Let's see, that's not it. I think we want Charles's Law. Yeah. The pressure is temperature in light. That's Charles' law. The temperature is inversely proportional to the volume at a constant pressure. I believe that's it. Okay? You can always go back and finish up. Okay. Everybody see? Is everybody looking? Not. Oh, okay. Okay. Everybody see now? Okay. Now, what we have is boiling water in here. I hope there's still some in there. See steam coming out the top? Okay, what I'm going to take that boiling water and invert it into hot water. Whoa! What happened? What happened? This is your answer. What page is that? Crush the can. How did it crush the can?
The volume inside. But instead it's like inside, and then like the outside's like freezing. So
Yeah.
it's still like contracting. I want to track it fast, and then like there's no place in there to go.
Okay. Very good there. We had very hot gas in here. A little bit of liquid, but very hot gas in here. When we inverted it over this, suddenly it not just cooled and contracted, it condensed and contracted. And when it goes from a gas to a liquid, that's really a condensation. Okay, that's getting much smaller. And therefore the volume got much less, pressure got much greater on the outside than the inside because the volume was reduced, and that's what crushed the can. Were you anticipating that? Okay, so on the molecular level is a better way to answer that question. Is the molecules were gas, and then when they hit the ice water, they condensed to a liquid, took up much less volume, reduced the pressure, crushed the can. The outside pressure much greater than the inside pressure. The can was crushed. All right. Have you seen something like that before? If y'all don't mind, I'm going to stop this and take the sink here. Yeah. Right. Okay. Very good question. Okay. If you go to the questions at the front of the lab, that's starting on page. Thank you. Question on page 149. Now, there's 5 questions there. If you leave these off, you lose points there too, folks. So get those 5 questions done. Number 1. Did the temperature change while the ice was melting? Yay or nay?
No.
No. Explain, offer an explanation for that observation.
It didn't change.
What's that?
It didn't change.
It did not change. Why didn't it change? What's the explanation? Because at that time, even though it was, yes. Number 1 on page 149. It did not change. That's what I'm hearing from most of the groups, right? I asked you to check that a couple of times, and you said it did not change. Offer an explanation. Why did not it change? Even though it was absorbing heat from the room and melting the ice into water, what you were experiencing was a change of phase, not a change of temperature. A phase change does not accompany a temperature change. When you have ice and water present in thermal equilibrium with each other, they stay at the melting point, freezing point, until either all the ice melts or all the water freezes. It stays at 0 degrees the whole time. Same thing about boiling and steam. It's going to be, you cannot heat water on normal pressure any higher than 212 Fahrenheit or 100 degrees Celsius, because any higher, it's going to change phase from water to steam. That's why when you're cooking at home and you bring the water to a boil and put whatever you put into it, if you cover the pot, you can turn down the heat. As long as it maintains boiling, it's not going to cook any faster. All you're doing is evaporating the water faster. You're not cooking it any faster. So that was number 1. Any other questions, 1 through 5? Okay, what are they? All right. Any other questions, 1 through 5? Okay. Before you leave today, be sure you pick up your last test. Oh, wait, you put that in. Oh, I did? Test date? Okay, great. Thank you. You did? Okay. What's that? Which one? Oh, yeah. If you didn't get all your old tests, I'll get them to you now. Did you get your new test? Okay. I left them in the office, in the other classroom. Go to the classroom, I'll get there and get them. Okay. Okay, you got test date already? You want it? Okay, here it is. Okay, here's test date. Okay. The test date. And if you haven't gotten your other tests, come to the classroom because I've got them in there. I don't have them here. Did you get both of those finished?
Yeah.
Okay.
I did one. The one that
Do you have an extra copy of test 7?
I'm sorry, I can't hear.
Do you have an extra copy of test 7?
I'll check. I think I do.
do one. I will.
Huh? Okay. Don't do it for them, though. Okay.
Oh, for
Test
test 7.
Anyone else need a test 8? Okay. Anyone else need a test 8? Last test. You need it? Anyone else need a test 8? That should be about all. Anyone else need a test 8? Okay. Now, test 7, I think I have in the classroom. I didn't bring the whole stack in here.
Can I write it down, my answers on the sheet of paper? Because I had the test, but I left it.
Well, let me give you a test if I've got it.
Okay.
Okay. So, does anyone? Okay. I can't hear you. It's cfowler@lawsonstate.edu. Yeah, it's on the store.
So I have a question. So these last two questions are kind of tricky. I don't know why. It'll be one was no, sorry. I'll start with three. Three is like account for any differences which are multiplied the melting point being 1.3. Like what exactly is it asking?
Okay. Why should there be a difference?
Because barometric pressure.
Negative. 0.07 degrees. I can't even read that, so I don't think that would cause any negative.
You're just like not be able to read like when it like measures like a T like we measure time like kind of like rounded it to like the closest number.
Okay.
Is it like
Did you think you were a couple of degrees off when you around it?
maybe I mean like I'm just talking like measuring it like measuring with a thermometer.
Right. Okay, now there you might be on to something. It could be calibration error. If you're reading the thermometer right and it was a degree or two off, that's probably, it could be one of two things. Calibration error, or you could have had some, that water was tap water, it wasn't pure water, deionized or something like that. It was just tap water. If it had things dissolved in the water, which it probably did some, that could have raised the boiling point, but it would have depressed the freezing point. So if both of those were high, I would say there's a whole thermometer that you can use probably calibration.
And number four, this one I was confused like the question.
Okay? Okay. It has to do, if there was a calibration error on the thermometer, if you didn't note that and take that into account when you're doing your measurements in the experiment, then you're off by however many degrees it is. Right. So then you wouldn't be taking accurate measurements. Right. So you have to account for any error.
Okay.
Does that make sense?
Yeah.
Okay. Okay.
I wanted to get my lab back too.
What's that?
I wanted to get my lab back. I need to change something on my lab.
The one you just turned in? Okay, I don't know where I put it, because people are handing them to me right and left, and backwards and forwards. Okay, I'm guessing it's not there. There you are. That one. Okay. Anyone else either have questions or need me in here? For any who need to pick up their old test, I'm going to be back in the classroom passing those out because I didn't bring those in here. I'll come get the rest of it. And what I'm going to do, if there's no more questions, I'm going to go on and start uploading this. Any other questions? That's not what I want.